the slides up for these guys. You most probably know René. He's brought along 2 techie people who know more than him. What we're going to do is find out why we should be doing this now. There's been enough time for talk. There's been enough time for consideration. We need to act now. As Kevin Anderson, the climate professor who supports the British Mountaineering Council, the BMC for England, has pointed out, since the Paris Accord, we've done an awful lot of talking and not a lot of action. So I love the enthusiasm. This is why we're going to do it now. So the 3 of them are going to come on stage and justify it. Every session is recorded. There are going to be questions at the end of the session. Just attract the attention. I'll give you the microphone. Don't worry if it gets too techie. I'm going to try and pull them back and keep it reasonably simple. But they are going to go into detail. And remember, when you play it back, sometimes it's easier when you hear it a second or third time. Because René, I've done an awful lot of work with. He's above my level. So sometimes I have to replay it. Anyway, the 3 of them.
So, hello everybody. Thank you very much for being here. It's also an honor to be on the panel. So you can see it. Oh, great. Okay. Introduction first, yeah. So, why I'm here with UPM on the stage, why I'm here on Performance Days, why I'm showing this to you, that's very simple, because we actually want to leave the fossil fuels behind us. We want to go a more circular way, starting from the source of the materials. And yeah, here I will give you like an insight of the project we are in and what we're aiming for, and also why we need you and your cooperation in the end for that. So yeah, okay. So in the end, we all know what we need in future. We know that we need renewable energy. We know also that we need to go away from the fossil resources. And we also need to go more in a circular way than we have done it before. So our aim in the end is that we at VAUDE, that we are ending the fossil dependency we are currently relying on. Why we are relying still on it? Because we're using synthetic fibers, synthetic materials in our products. And why we're using those? Because they're delivering the performance we need in the end. And also, when we're looking on the end-of-life perspective, it's also helping us here to just going in a better way in the recyclability when we're using those synthetic materials. So at VAUDE itself, we have set ourselves targets, so brand material goals, we're calling them. And that's by our collection, which will be actually in stores by next year, starting from next year, that 90% of all our textile products, they are made out predominantly out of bio-based and or recycled materials. And we also want to increase this amount in the near future. But so by next year, the entire VAUDE collection, 90% of that, it's already made predominantly out of sustainable materials, so bio-based and or recycled materials. Yes, but we have one big challenge, and that actually is a PET. Why it's a PET, the polyester? Because that's the most used synthetic fiber in the world. It's the most used fiber in the world. But also at VAUDE, it's the most used fiber we're using. And the problem is that we have not that many options. So far, it was like an easy target for everybody to set as a material goal. We're just going here for recycled PET out from recycled bottles. But you also know the difficulty with using the bottles. We're taking it out from another circle. And also the demand we're having if we switch in everything to recycled in the near future, it just won't be enough, because the most production of virgin PET goes not into bottles, it goes into fibers. And that's why it will be very challenging to switch everything just only one source in the end to the recycled bottles. So then the question is, can recycling ever be enough? When we see also those pictures here with all those landfilled and dumped textiles in the deserts and all over the world. So, and yeah, I'm handing over to Martin.
Yeah, I think obviously this picture suggests that it can't ever be enough. I mean, it needs to be 100%. So the ultimate goal for sustainable anything, not just fashion, is to actually close the loop and recycle as much as ever possible. But even then, and that's where we come into the game. My name is Martin Ledwon, by the way. I'm not a techie. I'm responsible for marketing and sustainability at UPM. UPM is a Finnish paper and pulp and forest industry company. But we've started diversifying and using forest side streams and wood to actually go into chemicals and materials a couple of years ago. And that's where I think the connection happens, because if we believe we want to go for recycling to the maximum possible extent, we have to acknowledge the fact that 100% circularity is not possible. You will always have the need for virgin material. Number of reasons for that. You lose material in the recycling process. You don't collect everything. The material wear off. And for these things, including also growth, that we will still see, even if we're all more sufficient and as part of sustainable lifestyle, you'll see the growth just by the sheer amount of people in the world and their consumption behaviors. We need to find an alternative for fossil-based materials to actually feed into this recycling loop. And that's where basically we started to build our business assumption on. We want to actually use biomass-based carbon to produce materials, chemicals that can go into synthetic loops. And the final goal actually should be that we use a fraction biomass, but long-term chemical, atmospheric chemicals, atmospheric carbon, power-to-X technologies to actually sort of feed that in. This sounded up until recently as a very long-term perspective on how to get towards renewable materials, but us and also other players in the chemical industries have started to scale now new sustainable production methods. So this is our refinery in Leuna, and we're going to go live end of next year. It's a biorefinery where we actually use residues from beechwood and beechwood taken from forest management practices to produce glycols, one of the ingredients that goes into the PET that René was alluding to, and fillers that go, for instance, into rubber applications in the end. We operate also refineries where we use side streams from the pulp industry to produce fuels, but also naphtha. Naphtha being another ingredient for PET. And looking at scaling this business to actually go into the €1 billion revenues sort of dimension in the next couple of years. So here, VAUDE leapfrogging in terms of taking a step and using renewable materials, the industry pushing new materials into the market. There is a reason to believe that we don't look at sustainable textiles in the future, but we can actually go there now. And then Gerd is going to go a bit further what options we actually see from renewable chemicals into textiles.
Yeah, it's a pleasure to introduce you a little bit more into the technical details. As Martin explained, we have different sources for carbon in the future, biomass, CO2, but mainly recycled materials. And our MEG, our bio-naphtha, and also our functional fillers can bring a sustainable solution in these very complex value chains. So just to give you a brief intro into the world of chemistry. So we start with classical fossil fuels, and then it's fractionated. You produce then the polymer is compounded, additives are added or filler materials, and then a fiber is made, a textile is made, and then the garment which you can wear. And the bio-naphtha and also our bio-MEG, which we are both producing out of woody biomass, and also the functional filler can be entered into this value chain. So very easily, without converting the entire value chain, we can replace a fossil-based raw material with a bio-based raw material. And also the charming thing is that this is just the beginning. Technology-wise, you saw the refinery which we are building up in Leuna. And if we are looking more into wood, into detail, then we are talking about sugar as the main raw material. And I gave you some examples on that slide. So you can find PET, you can find polyurethane, but you can also find polyamides. And all these stuff can be used to replace fossil-based raw materials. So it's a very versatile platform when you start with wood. So talking about cellulose valorization as a fiber is one option, but if you break down the cellulose, if you break down the hemicellulose to the sugars, you open up a broad variety, which is much, much more versatile than the cellulose fiber itself. In addition to the biogenic feedstock, we have to think about using CO2, so we can capture the CO2 which is generated during the production processes, and using so-called power-to-X techniques, so using electricity to produce enough hydrogen to convert the, let's call it dead CO2 molecule into more valuable intermediates like synthesis gas or methanol, and then you end up with naphtha again. So at the end of life, you can always produce a synthetic material back again. And this is very important to adapt also these recycling technologies, and also talking about chemical recycling. And we have also some booth over there in hall number 6 dealing with this topic, because PET is just one product class. If we are talking about polyurethanes, polyamines, we have to recycle them, we have to renew them, reutilize them. And at the moment on the graph, you can see most of the material is only used energetically or landfilled at the end of life. And this we have to change. And one option to recycle also this is, as said, chemical recycling. And this is also a very complex value chain. But as a take-home message, also our BioEconomy, so ethylene glycol, can be used to recycle polyurethanes. So it's a very versatile chemical which we are offering from our plant in Leuna. And this offers us to do chemical recycling, produce new materials out of recycled one in a virgin quality, but also using woody biomass as a feedstock to produce also virgin fiber materials. And as said, in the future, CO2 is then also a topic which we have to take into account. Martin, would you like to summarize the talk?
Yeah, I think we stop here, and we hope we didn't go too deeply in there. I think the main point is we want to, I think the challenge that we all have is there is a technology that's invented that's scaled. That needs a market, and that market needs belief in the viability of that technology. And I think that the reason why we're teaming up here, I think, is precisely this, that we actually want to sort of bring this to the public to also sort of instigate a trend that basically we accept that there is solutions that go beyond the PET to polyester recycling, solutions that go beyond thinking about a prototype. We see scaled up solutions in these areas. So ours is one, but there's other companies in the chemical recycling space, but also in the biomass-based chemical space that are starting to produce this in scale. And I think the main message is that we should start switching towards these new solutions now. And also materials producers, textiles producers should think about switching to these solutions now. Beyond prototypes, really going for it. And I think that's what we're trying to advocate here with that talk. So, thanks.
Yeah, exactly. So what is really nice on this project is also from the feedstock itself that it's fully traceable, because it's something what's happening here in Germany. It's something where also the feedstock, so the raw feedstock, so the woody biomass is also coming from the area actually. So it's coming close by Leuna from the forest, and it's fully traceable. It got all certifications which are needed, and in the end we're making like a basic polymer out of it in the end, like the MEG into the PET, and the PET will have the same properties, the same functionalities as the conventional fossil fuel PET, so no change in machinery equipment, no change in the spinning equipment, so you can use the same processes as before. You just at the switching more or less like the feedstock source in the beginning. And that's also something really good, because when we end up with more and more new materials coming up, new material types, we always face the challenge, what about the end-of-life perspective? What about the perspective on recycling, recyclability? Because we see already that we have a huge challenge with textile recycling with the existing material types. And so we should not enlarge, in the end, the variety of different materials. into our products. So PET is a good material. The problem is, so far we have it made out of fossil fuels, and also what I would also give you is that it's not only one solution in the end, that there is not only one final solution we will use in the end, and that's why we're looking on all those three different pillars for renewable carbon, so from the CCU to the recycling and to the biomass, where we also know that the recycling is one of the most important topics, but also we really need to start from the very beginning, because if we still just focusing only on recycling, as Martin mentioned, we always need fresh material. When you just consider like the very traditional bottle-to-bottle recycling or bottle recycling, for example, PET bottle recycling, mechanical process, you have a loss already of 25% about in the process itself. So it's just been gone. So you always need kind of fresh new material. And this you should definitely start with renewable carbon. And this option now is something what is super viable. It's scalable. It's also important. It's not just like an idea. And that's also why actually we are showcasing now on ISPO the first product out of this material, including the MEG, the bio-MEG, and just to demonstrate also it's possible to make functional products out of it just right now. And yes, what we also need, of course, is we need partners in this game to help us also to scaling this up to make the change happening. And that's why it's time to turn ambition into action. And yeah, the solutions are more or less there. We just need to adopt them, and in the end, we need all of you in this. So with this, do you want to add anything?
I think we're good.
I guess, Charles, you want to add for sure some stuff. So thank you very much.
Initially, I just wanted to point out, thank you for showing your appreciation. If you did not grab this, don't worry. I didn't grab it all, but I want to ask you guys a couple of questions on it. This session is being recorded. At the end of this month, it will be uploaded. You can watch it back a second and third time. I work with René every single show, and he always raises the bar of my information. Now, I am very happy to moderate questions, but I will start off with what I think is a more obvious question, which, coming back to the opening statement, and it was also your closing statement, we need to work together. We need the collaboration. Normally when people collaborate, they have to compromise on what they're looking for. But I'm reading here that I can get excellent product without compromise. Does that make sense?
Yes.
Easy answer. I like it.
Yes, actually, we are always aiming for traceability, for transparency also in our industry, and it's really difficult to going in the upstream supply chains, but here we do have it because it is starting with UPM and then it goes downstream to our textile processing. So we just have a full, clear supply chain.
Chemically, it's the same molecule, and therefore you can replace it one-to-one, but with a much better CO2 footprint.
I think it's not compromising per se. I would agree, everything is there. It's a good product. It's technically fine, and it's usable already now, or will be from our plant at least next year. But I think when we look at the bigger target, sustainability, I think there comes a bit of a caveat because we're still in the beginning of a transformation. So I think that may be the only thing towards a compromise, that we start scaling that, it's going to grow, and the effect is seen basically when we have more scale there. So that's basically the point. There is a bit of patience in there. You start with substituting parts of it. You aim for substituting the entire sort of components of your product with non-fossil ingredients over the time. I think that may be the only caveat, but technically, performance-wise, and also from the sustainability footprint, it's no compromise.
Okay, Charles is going to bridge that into simpler language for the audience, because I feel that we're not quite bringing them on. You're not yet engaging with questions. We're all aware of the EU Green Deal coming in very soon. It is legislation. When legislation happens, if you do not meet legislation, you stop operating. I don't want to make a big thing about it. You either meet it or you fail. It is coming in 2 years' time. It includes textiles. The quote is up to 20% of the market is going to be affected by it. You've just had a wonderful way to show provenance. The 3 areas that are most on textiles, we have an eco-design module, we have a transparency or provenance one, and we have a green claims. In simple terms, you've given us perfect provenance, haven't you? Yes. They keep on saying yes. I like it when they say yes to my questions. I feel I'm there. But does anyone else want to ask them about more specific things? Because I have to say the chemical formulas, I recognized 2 of them. I didn't take them all on, which is why I've got to go away and study them again. But does anyone want to ask a more techie question than Charles can come up with at the moment? Because if you don't, I'm going to fill them full of the basic stuff. Christine is going to try and raise the bar of us all.
Hi, thanks for the interesting presentation. We are talking here a lot about LCA and gathering data about the impact of different materials. And I'm wondering if you have done LCA on your products and if you have done comparison with virgin polyester, because yeah, that would be interesting.
Yeah, okay, I will just hand over then short to Gerd. Yeah, but we have not done it on a product level now because we just have now the showcase. The showcase won't be commercial because it will be just including the 30% MEG from UPM. We're working on the remaining 70% of the terephthalate acid. We're working on that, but there's an LCA available from the MEG. So.
Yeah. I think that's we run LCAs for all our products and constantly update. And the value of the LCA essentially is for us having a model to understand footprint across the entire process, from feedstock sourcing through production. And at the current state, our refinery is configured to the point that we end up with a carbon zero, net zero product when we enter the market. But the focus is also on taking that further down. By, for instance, switching the energy mix in our refinery towards renewable, by looking for alternative process chemicals and so forth. So LCA we have, it's net zero at the point we bring it to market, but we're aiming to actually constantly improve that because that's one of the main, I think, value arguments that we have behind the product, except beyond that, it's renewable. Basically.
Okay. Thank you.
I love it. People think I'm going to come up with a technical question now. Christine is a specialist within the trade. We're happy to take more questions because otherwise I'm going to ask you more about the process engineering, especially what you've just said about net zero. As Shunard said, everything we do has a footprint. You are now counterbalancing in that you're giving us permission to have product which has a lesser impact. At the moment, that's 30% effect to what René's wanting, so that he is mitigating himself. Looking towards the European objectives of net zero as a continent, we are firmly stating this is where we want to be. How much more have textiles got to change? You're leading the way with your specific area, but when you look around the wider industry, how concerned are you that the industry is not on board with this at this stage? It's a more philosophical question. This is what you get from an academic. As in, you're doing all right, but how about the rest of us?
Yeah, in the end, and we are not an exception, it will also come in the end to the price point. So the price is a big barrier, but also in the end, we need regulations, as you have said before. There will come in regulations up where actually we are obliged to fulfill those. So I guess a lot of people still think, okay, is it really a sustainable solution, or where are maybe some cons on that? And a lot of people are very skeptical, and I also thinking, okay, bio-based, I'm also a bit skeptical on that. And Also, as I mentioned before, a lot of people thinking, okay, they just think about the one solution. What is now the best option? What is the best solution? There won't be like the one best solution. It will be like a variety of different ones. I'm just saying it a bit like with the renewable energy. With renewable energy, we know we have mainly three different input streams, like hydro, wind, and solar. And all of them have pros and cons in the end, but that's what we have actually, and that's where we need to aim for. And we should not actually, saying something against the other ones in the end. So we just have to look very closely on that. And LCA is one tool, and that's what we have. And also here we have a very transparent LCA also with UPM, and I guess that's a good baseline. But furthermore, it's also about the whole the transparency in the entire process chain. And when you're starting with the raw chemicals in the end, you need to go all the other ways downstreams. And it also gives you more the confidence of what you're doing in the end, and not just purchasing in the end just a fabric where you don't know what kind of steps has been done before. So I don't know if it's answered now your question, but
I would like to sort of maybe I think it answers parts of it, because your question also points to what do we need to do beyond these things. And I think that the point is, I mentioned one topic. I mean, more forcefully go in there and demand, because I think if you look especially at synthetic fibers, which is still a big share also in the textile industry in the future. If you look at chemical industry in Europe, it's around 500 million tons CO2 equivalents per year. And even if they would go for a fully renewable energy supply by 2050, still around 50% of these 500 million CO2 equivalents will remain due to the fact that they use fossil feedstocks and in the end of life of their products. So I think what we have to do is basically demand an acceleration of the provision of alternatives through chemical recycling, through other renewable materials. And I think there, any industry, packaging, textile, automotive, they play a role by making much clearer than now, we need this sooner than maybe 40, 45, where we see at the moment a scale of chemical recycling happening. We need that earlier, and demand plays a key role. I think that's what the textile industry could be doing there, if you answer your question.
No, I like that answer. From a design point of view, we know we never get it right the first time. We need to iterate, we need to try it, and we need to be more resourceful. So if I throw the question back to you guys, because you aren't joining in, what questions should we be asking our supply chain? What should we be asking specifically to them? Unfortunately, we now know UPM, you've got a solution we can work with, the first chance solution. But when we turn round to the rest of our supply chain, please help us. What should we be asking our supply chain? Because you're thinking ahead of where we are. We would like to borrow some influence from you. What questions do we need to ask our supply chain?
Okay. Making up, I'm more good at giving answers. Sorry, no, but I think it really is sort of, it is the question of what transformative material can you provide us with in the nearer future? How can you help us market this kind of sustainability transformation towards our customers? Because also they have to be educated. And I think how much influence are you willing to actually take on your sort of partners to actually accelerate that transformation? Maybe 3 questions, but probably there are other ones.
I have not much to add on that. So in the end, it's a bit of a willingness which need to be there, actually, like a motivation of going in the transformation. So if this motivation is not there, it just will come by regulations, but it would be good to have some motivation in the first place, because otherwise that other players are moving up front and leaving you behind. So that's why the motivation should be there, and yeah. And again, it's not all about the price in the end, because it's also about the story behind, and the story you can communicate. And by the way, I'm just wondering that there are not many questions or no questions coming here from the feedstock itself, because often when I'm talking or we talking about bio-based solution, bio-based materials, usually the questions are coming just for the feedstock. Is the feedstock sustainable when not harvested and so on, but coming no questions. So maybe we just answered all already.
Maybe they are all forest experts and they know that there are regulations in place like PEFC, FSC certificates, and of course this is our recommendation also to have a sustainable forestry as feedstock supply for the plant.
We do have some questions. You've stimulated them, but I want to come back to something you've said, René, in almost a throwaway comment. The next generation, Gen Z, who I work with very closely, they're aligning on values. And you've painted a wonderful picture. But I'm going to go to the first of the questions.
Hi, Laura. So I maybe have more a technology question about it. So now for your showcase, you told us that you use 30% of this woody-based substitute drop-in chemical. So why just go for 30%? Why can you not increase the value? So what is, or the amount of it? So what are like the main challenges to introduce this substitute into the market and into the production chain?
Yeah, I can answer this because the PET consists out of two components, so ethylene glycol and terephthalate acid. And the one ingredient, ethylene glycol, makes about 30% of the PET, and the other one, the terephthalate acid, about 70%. What UPM is doing right now, or what the UPM is doing in Leuna, will be the MEG, so the ethylene glycol, and this we're using 100%, but it just makes 30% in the PET. We are showcasing this just to demonstrate that it's possible to make functional products out of it. Even so, the 70% remaining on the showcase will be fossil-based. But for the commercialization we're aiming for, we're also working right now with UPM together to get the 70% also from the stream from renewable carbon. But it won't be exactly the same stream like what is happening there in Leuna. So that's quite a complex part in the end, and also working then with a polymerization company together. That's also a crucial part. So it is quite tricky to do that, but that's where we're working on hard on. But it's, again, that's the first step, and this is something what we can do right now, and step by step we are transforming it to the 100%.
Yes, Markus from the University of Jena. And sorry, my question aims not to your feedstock, but to your product. So did you check the recyclability of your final product? So because you use pure PET, recycled PET, and make a high complex composite material out of it. So is it good, or does it have a good recyclability? Like a PET bottle is pretty easy because it's pure PET. You can melt it and use it again. Like outdoor wear, you have like 3 or 4 layers, different materials, you have colors in it and so on. So how is the recyclability of your product? This would be a main question for me.
Yeah, so the showcase we're making is a fleece jacket, and it's not like a waterproof jacket. So the fleece jacket will only consist out of PET textiles. Meaning actually this can go in existing recycling facilities. To open up a bit more broader, we are just launching in the next year to the market a collection at VAUDE which is made to be recycled, which is only consists out of PET, so not just any copolyesters, it's just PET, and where we made also testings that it's possible to go here in existing chemical recycling plants. So that's possible. We're not advocating it too much because we don't have the reverse logistic in place. We tried it already in 1994, the system. We set up this kind of system, but we didn't get anything back. So that's actually the challenge for us with the reverse logistics. Yeah, you know it very well, Ulrich. Yeah. that's a big challenge in the end, that our products are lasting quite for a long time, and they should also last for a very long time, and that's why it's very difficult to get them back actually and also to feed the stream. But from the technical point of view, it's no problem at all to feed this into existing chemical recycling PET plants. Because here it's just important that it's made out of PET, and this confirmation we do have. We will also have, by the way, when we're showcasing the product on ISPO, we will also have the proof that it's consist in the material like with a BioMEG, so it's not like just any kind of other material in it, so it is the UPM BioMEG in it, and we will also have a proof on that.
Can I come back to you on a slightly different point of that? Because we're not talking about it now. Are you aware of Textile Exchange withdrawing the license for chemically recycled polyesters is coming in? I think that's going to upset an awful lot of the industry, because the EU Green Deal has recommended chemical recycling, but that's where we're going to lose the GRS certification. It's only on mechanical. No.
No.
Have you got a better update than me?
Yes. So Textile Exchange was launched in July or August. They launched a revised GRS annex. It's the Alternative Volume Reconciliation, VR2, which is including also mass balancing, which is also including chemical recycling from pyrolysis and gasification, which certain kind of claims you can make then, which is also mentioned in that. So it's free to download from Textile Exchange. So that's in place already under GRS and under RCS. And by the way, the chemical recycling itself, like depolymerization, it's already under GRS, so since ever.
By the way, the next panel we're going to go into more detail on mass balance, and we're not letting René escape from the stage. I'm still looking for questions around the audience. I have one from Ulrich.
Now, let's imagine this plant in Leuna will achieve 100% bio-based. You find the solution. And the production of the products which from our industry is not in Germany. So what is the question? What is the answer on this? Because it's great to have bio-based polyester made in Germany, but the production sewing of the products which from our industry it's basically in Asia. So what's your answer on this?
Well, I mean, you can answer that from a manufacturer's point of view, but I think what we're seeing is that there is an interest in our product that is way beyond Europe. So one of the first, I think, bigger commercial successes that we are closing, are in the process of closing and building a partnership, is in Korea, for instance, where they use our product, for instance, for the production of soles into the local then shoe production in there. So I would say that especially in the more developed, I think, production contexts, there is a clear pull that we're seeing, and ultimately we are a drop in the ocean with our annual production. But I think what we can do is that we showcase it's technically possible, and it's commercially viable, and it's viable to actually use this beyond Europe, also in the areas where there is the most textile and also shoe production in the end. If that is a lead into an answer to your question, you can probably go further, but I guess especially in Korea, which is a market that we've been looking into, I think, quite a bit, there is a clear push to also defossilize their local chemical value chains, clearly with a focus on textile industry, and they supply a lot of the neighboring countries in South Asia, for instance.
I can add on that the ethylene glycol won't only go in the PET and in the polyesters. There will be other applications as well for complete different industries, which are situated in Germany and in Europe. But for us, it was also, of course, a question how would be in scale, because, to be honest, our main polyester production is not happening in Europe, and it also won't be in the next year. So what we figured out, and this is something what we experienced also with another project in the past, that it's difficult to ship yarns overseas because due to quality, also due to price, but to ship like chemicals overseas, that's something what is already happening a lot. And that's no problem at all. And we demonstrated it also with another project, with the BASF C-Cycle project, where it's been produced, like the master batch has been produced in Europe, shipped to Asia, shipped to Taiwan, and is now running under really high capacity, meaning we started there, as you probably know, with 4 styrets, and now we have 100 styrets made out of this waste tire stuff there. And it's no problem actually that to ship it from Europe to Asia. It is like the basic chemical or the master batch. And yeah, also from the environmental footprint here, as we all know, that the shipping itself, it's not really counting much in the LCA.
But even this you don't need, because our intermediate is glucose. And there are many, many sources for this glucose intermediate to produce then MEG worldwide. We are a forest-based company as UPM, so we start with forest biomass, but you can produce glucose also of annual plants or other raw materials.
I'm going to turn back because we need to wrap up, because there's a panel that we need René for. What leaving comments would you like the audience to wander away with, other than what Charles said earlier? You can play this back, because it is not an easy subject to get your head around. When you do get your head around, you'll suddenly realize why we must be doing it and why we must be doing it now. But what would you like to leave the audience with as justification? You know, what do they need to think about as they wander away?
Well, I mean, it's a simple thing. I mean, if you believe this makes sense, you can help scale by actually looking into using the materials, ours and others on the market, and by helping scale, you make it happen. And I think that's the transformative step towards a more sustainable material supply that we need globally. I think you have a role in this.
For me, it's about transparency, because it was always a challenge when we looking into new technologies. And here we have a full transparency, so raise all your questions in advance, look into it, and make a decision, and you will see that's a potential solution you can use for PET.
Yeah, and use the time today to visit us at the sustainability launch in Area 6. So we welcome you all to partner with us.
And on that note, can we show our appreciation once again for the panel?